Hello everyone, welcome back to Tech Wizards. And today I will be talking about the blockchain technology. So we can think of blockchain as a decentralized immutable database inside which we can store any data. So what do I mean by immutable? By immutable, it means that once data is stored inside a database, no one can alter or change that data. So let's dive deeper into how blockchains actually work. So it was developed by a person named as Satoshi Nakamoto in 2008, who used blockchain technology to transfer cryptocurrency, which he called as bitcoins, from one person to another without relying on any third party like bank. So when we send money to any other person using any of the payment method like PayPal, MasterCard, we rely on bank to validate and carry out that transaction. So before understanding the blockchains, we should know about the different kind of network architectures that we have. Inside a centralized architecture, all users are connected to a central server, just like we can see over here. So most of the internet that we see today is based on the centralized network architecture, whereas the distributed network architecture are mainly used with the central network architecture to increase the potential of the central server by increasing its storage area and computational power by distributing it among the multiple nodes in a distributed network. In a decentralized system, there is no single authority that makes decision on behalf of all the parties. So, in centralized architecture, we have a traditional database, whereas in decentralized network architecture, we use the distributed ledger. So let's look at an example about how bitcoins are transferred using blockchain technology. So inside a Bitcoin network, all the nodes have the list of all the transactions history which has ever taken place in the network. And that history is stored as blocks in every node in the network. So, so if someone in a network requests a transaction, then all the nodes who are working as miners will try to validate that transaction. There will be a competition among them, as the one who will be successfully able to validate that transaction first will receive some reward, and that reward is in the form of bitcoins. And once that is done, all the details regarding the transaction is stored in a new block and is broadcasted in the network so that all the miners in the network can verify that block. And if it is correct, it will be added to the already existing chain of blocks. Like we can see over here, it is added to the already existing chain of blocks, or else it will be rejected. So let's see what task is performed by the miners in the network. Firstly, they check whether the transaction amount is requested by that person is there or not. And once that is done, depending upon the kind of consensus algorithm used, they need to perform their task. So if proof of work algorithm is used, then they need to solve a complex mathematical problem. So let's see what this mathematical problem actually is. Firstly, the hash of the contents of the new block is taken. Then a random string is appended to that hash. And the final hash is then compared to the difficulty level and seen whether it's actually less than or not. So what do I mean by difficulty level? By difficulty level, I mean as the amount of the blocks which can be generated in an hour is fixed. So the miners need to find that hash value which is less than the current difficulty level. As more and more miners join the network, mining difficulty increases. And if there are less miners, mining difficulty decreases. This is done so that the average mining time remains same for the generation of new block. So, proof of work makes it extremely difficult to alter any aspect of the blockchain, since such an alteration would require remining all the subsequent blocks, which is very expensive in terms of the computational power required. So now let's try to understand this with an example. So as we can see here, It's written proof of work, and it consumes lot of energy and it requires hardware and lot of time too. So we begin from here. We proposed a new block, combine and hash, and we attach header of the most recent block to it. Then we have a hash number and we check, is hash less than the target value? If yes, then we have solved the problem and we get the reward. If no, we increment and try again, and nonce an incremental number. And this task repeated until the condition becomes yes. Here we check the target value, determines and mining difficulty. So we can see that there are few issues within the proof of work algorithm. First of all, it is very slow, as it takes around 10 minutes for the generation of a new block. It requires a lot of computational power. Anti-miners or mining rigs consumes a lot of electricity for mining, which affects environment. To overcome all these issues of proof of work, proof of stake algorithm was introduced. Here, miners do not need to solve any complex problem. Here, miners are not competing against each other. They put stakes over their blocks. So higher the stakes, higher the profit. In proof of stake, nodes having no stake involved cannot mine. But if the block generated is wrong, miner will lose all the stakes which he has put over his block. So we can say in proof of stake, rich becomes richer and poor remains poor. So let's see what items are actually present inside a block. It contains data about the sender, receiver, and the transaction amount. It also contains the hash of the previous block. Thirdly, it contains answer to the complex mathematical problem. The final hash, which incorporates all this information, represents this block and is unique for every block. Now let's talk about Ethereum. Although each uses blockchain technology, they have different goals in mind. Bitcoin was designed to act as a secure peer-to-peer decentralized payment system. Since everything is shown on the public ledger, the blockchain, you can be confident that the transaction is legitimate and there is no need to trust any other party. Security is Bitcoin's first priority, followed by speed. The current reward is 25 Bitcoin per block. This reward halves after every 210,000 blocks. There will be finite amount of Bitcoins ever created. So talking about Ethereum, Ethereum was designed to be much more than just a payment system. It is a decentralized system that runs smart contracts. These are the applications that run exactly as are programmed without any possibility of downtime, censorship, fraud, or third-party interference. And the reward per block is around 5 ethers and they remain constant, unlike in Bitcoins, which changes. It does not halve. And Ethereum block times are currently 14 seconds as compared to the 10 minutes in Bitcoins. So we can see the comparison in the times taken in Bitcoins and Ethereum is very huge. So let's just wind up all the things that we have studied today. We have studied that blockchain is a kind of decentralized, immutable database which can be used for storing any data. In Ethereum blockchain, we can write smart contracts which can perform any task, not only transferring cryptocurrency as in Bitcoin blockchain. And we use proof of work or proof of state as our consensus algorithm. So that's it for today, guys. And in my upcoming videos, I will be going in detail of what smart contracts are, and we will be writing our own smart contracts, and at the end we will be deploying it in our test network. So stay tuned, and if you like my videos, don't forget to like, subscribe and share. Thank you.